Hello, everybody. So we're getting very close to the end here. The semester ends next Tuesday. So we're less than a week left in the semester, then a bit of a break before summer classes, or some of y'all might have decided to take the summer off and have a nice long break coming but still a few more things to finish up. We've already seen, I like to front load courses. So when we get to the end, there's time to work on projects and go back and get homework assignments that might have got missed or past due things, and have time to do all the catch up and get everything finished at the end of the semester. So when we get to the end, I usually have some odds and ends to go over, things that I think will be very useful for you. One of the main things I intended to go over today I need Microsoft Office installed, and I don't want to install it on my own laptop, and I forgot to bring the laptop from my office when I came home last night. I had a big armload of stuff and I grabbed a whole bunch of it, and I'm so used to leaving the office laptop there in the office that I forgot to include that in my pile. So I guess that part will get pushed back to Monday, but I have a much longer list than we can cover in our available time. And like the other day, I've got a few things. We'll go over a few things that'll hopefully be useful for you all whichever way you're progressing from here, and then leave lots of lab time to actively work on stuff, because this is an active subject. We learn so much more by doing something than listening to me talk about it. But before we break off into the actively doing stuff, a little bit of talking. And let's see, where's a good place to start? Well, I'll go over one of the office things I was going to point out. I was going to bring my computer from my office because it has Microsoft Office, Word and Excel and PowerPoint installed on there. I tend to not use those. I'm a big phone person, so I use Google Docs and do most of my typing on the phone, or dictating and swiping with my thumb. And the big keyboard is just for like some final edits or something, if I even use that. So I tend to use Google Docs a lot. So that's what I have on my own machines. And then, yesterday I left the office and forgot to bring my the laptop from my office. But one of the things I was going to show there involved related to spreadsheets, and it'll work in Google Docs just as well. So I'll just open that up, and kind of a pointer, something to keep in mind, or maybe just a spot where this knowledge will apply directly. Has everybody used spreadsheets before? A little? I think in most our society, they tend to show up, right?
Yeah. Are you going to talk about
I
call to
haven't
functions
used
and
like
stuff?
Google.
Yeah, I was going to talk about the functions related to what we've done in here, because hopefully that is one place you've probably seen spreadsheets.
I've learned about spreadsheets and with the Excel on informatics class, and we did it talking about how to program like.
Okay, so you've seen them before. I was just going to point out a couple things here. It's very common software. Technically, it's accounting software. And just like in the old days of paper, if y'all ever saw that old columnar paper, the green paper accountants used that had the grids and boxes and everything laid out really nicely, accountants had the best paper. And in many aspects, when everything moved digital, accountants ended up with the best software. Excel can do a lot. So we have this big grid where we can enter data and type in numbers. And the things we've been looking at in this class, a lot of the logic applies here as well. So
Yeah, plus you
skills.
said that you could program certain things through spreadsheets, right?
Yes, you can program anything in spreadsheets. I've programmed games in spreadsheets before. It was very, very tedious, a whole lot of work for a very small game, but it was a proof of concept. It was just to prove to somebody that you can use Excel to program a game. But those things we were looking at, so each one of our grids kind of stores values. Can put some numbers in some of these. I'll just type some random numbers. 311, and each one of our cells here is holding a value to be worked with. Right? We can come down here and find the sum of them. There's some pre-built functions we can use, like equals, and well, it automatically predicted, well, there's a bunch of numbers, probably want to take the sum of those. So we can call that pre-built function, which should look a lot like how we were calling functions in Python, right? We type a name of it, followed by parentheses, and then some arguments that are needed to carry out that function. And just get the number from them. But every cell is kind of like a variable. Like this cell is named B4. I can change that. Call it first number. Then maybe rename this one, instead of calling that cell B5, I don't know, below, and other number. Well, if I try to put a space in here, you'll see we have the same naming restrictions like we do with variables. So those cell names are actually variables. So when we look at this, it is a big collection of variables. So when we organize a bunch of numbers into them, that kind of is what we were doing with an array. And we can do more than have some other ones. You may not have seen this. It doesn't show up as much in things. Several of our programs involve random numbers. We can do those in spreadsheets as well. Rand gives us a random number between 0 and 1. That's kind of like that thing we looked at. Number that includes 0 but not 1, so 0 to 0.9999999. So if we wanted to say represent a deck of cards like the one we did, we can take those small numbers, multiply by 52, and then wrap that in parentheses and floor that number. That should look very familiar for what we did when we looked at a deck of cards, right? Some random number, which is a probability, so between 0 and 100%, but it doesn't include that certainty of 100%. But a random probability, multiply it by 52 to make it bigger, and then floor it to get an integer. And then, yeah, create a large collection of them, like an array, to represent a deck of cards. Tying it back to the example we saw in class. With Excel, you would probably have a particular use, but I was trying to tie it back to class example to show that after taking this class, the logic we've been looking at should apply directly to what you do in spreadsheets and give you a lot more capabilities. Selection structures, that's one a lot of people don't use right off the bat. Have a if, and ifs is multiple if statements. So that's like an if else, or sorry, if else if. If we just say if, then that's sort of like an if else statement. So we put in some condition. I'll say maybe this this random number is less than 26. Then a comma, and then we'll pass in two other things. I was going to use Excel for this because Excel has little hint boxes pop up to show how to use the functions and stuff, and Google Docs doesn't. We have to actually go to another website for the Google Docs one. I guess I could go over there in a second. And with the if function, then just like in our if else structures, there's one thing we do if it's true and another thing we do if it's false. So maybe, whoops. I didn't mean to type that. Maybe instead of 26, I'll say less than 13. So that'd be our cards. Like when we look at numbers, there's 13 in each suit. So maybe that's our spades. We could say those are our spades and print out that word. not a spade, and sort of organize those numbers like a deck of cards to tie back to our example. Did you notice that about the random numbers? They already changed. If you haven't worked with random numbers, every time we do something, they randomize again. I type some words in down here and we get a different random number. More stuff type. So random numbers in a spreadsheet are very random. Every single time you make a change to your spreadsheet, you get a different random number. Just in case you haven't seen that before.
That's nifty.
But that logical structure, the if else, like we've been looking at in this class, the making selections, it can help accelerate your spreadsheet functions. It also gives you a powerful tool for designing your code. We talked about pseudocode some, that thing that's halfway between English and computer code, and helps us organize our thoughts so that when we're ready to maybe type up some Python code, we already have the thoughts in order. So all we have to do is quickly punch the buttons to type it up. And having those same logical tools here gives us another thing like the pseudocode or flowcharts for planning phases, and that we can do little bits and pieces of planning and test stuff in a nice organized format. Some people like to prepare code that way. We haven't really seen that. I just wanted to point you towards it in case you haven't seen it before, that under insert, there's all these pre-built functions, which was a whole lot of what we were doing in Python, right? And when we were doing stuff in Python, we were calling pre-built functions and would just save a handful of values. And when we break it down, that's really what a spreadsheet does. It's a graphical interface that allows us to save a handful of values in a nice organized format. It automatically gives them names, which are based off the table position, but we can rename those. And then just like in our programming language, we can call some pre-built functions or do some logical operations like the selection structures we were looking at. If the if is an if else, so we put a condition and then what to do if it's true, what to do if it's false, what to do if it's false. Ifs, IFS, that's like an if, else if, where we have, or elif in Python, where we have a whole bunch of conditions to check. And we can do a whole lot of those logical things. And then our operators, or and not, and XOR is probably on there somewhere. But those same similar things apply. Oh, that's why I wasn't getting the predict. I didn't realize that was there. Okay, I do have the predictive thing. So there's a little question mark here that shows what to do with it. And then the things that we've learned in this class should be very, very useful for you when you go to do stuff on a spreadsheet. We have those same capabilities. We look at a couple of the functions. I didn't want to spend a lot of time on this. And look things up, that can be useful. But the logical operators, that's one we spent a lot of time on this semester. Different things for working with arrays. We talked a little bit about those, not a whole lot. Different things for adjusting what we have in our text, concatenating and parsing through text, cleaning it up. A lot of those same pre-built functions are available here as well. Most of the same ones we would have in any programming language for math. Doing, you probably don't know a whole lot of those by names, but sums are obvious, but square roots and rounding, floor, ceiling a number. So the abilities we have in a spreadsheet are very similar to what we've studied in this course. So keep that in mind whenever in the future, if you have to go work on spreadsheets and things, because the logic, the things we've studied in this course, looking at software development, apply very heavily there. And spreadsheets are something you will see in just about any industry. So no matter which pathway you're heading on, you're probably going to end up working with spreadsheets some. And it's just a different way to input the logic, which is something I wanted to talk about here. We've looked at a couple ways to do this semester, right? We, I came up with a new way to introduce this from what I've done in previous semesters. So I'll just do a couple quick things. So if I go to Raptor first, that's one we looked at a lot. Get that nice visual representation. We can make a flow chart. Maybe ask a user for their name. Input your name. Store that somewhere, and maybe loop out a message and just keep printing hello or something. Set counter to 10, and we'll go until counter is less than or equal to 0. Decrement counter every time. Nothing fancy here like we've seen, and just, I don't know, print out a message. Hello plus name. So nothing fancy. And we drug those pictures around, and when we hit the run button, the computer does something. Type in my name and get a bunch of messages printing up over and over again, or turn up the speed. Don't need to watch that slow. But just like we were looking at in Excel, it's there's a graphical thing, and we put in these basic instructions, and the computer makes sense of it. This type of thing, we could also generate some code out of it. Oh, have to save it. Then I can generate some code. So drawing this picture of a flow chart. Whoops, I hope I did not just say to do that with every file. I'll change that later. We drew a picture of a flow chart, and then it put together, wrote a bunch of text-based code in the background. And this is more what people think about when they're looking at when they think of programming, right? Sort of like we were doing in Python. We write a bunch of text, but that's still not quite what the machine does. Let's think about what text is. Onto our box here. Really, when we put a letter in there, 4, 5, 6. I think that'll be enough. Even when we type in text, that's really just a picture. It's a bitmap. For example, if we split up and look at a bunch of pixels on the screen, maybe we turn that one on, and that pixel on, and that pixel on, that pixel on, that pixel on. Turn on all of these. A couple of these. Oh, I guess I didn't need those extra ones at the bottom. That's probably enough color. I'll take those off. So we just have a bunch of pixels that get turned on and off, and that means something to a human. But it is just a picture, right? We spent a while talking about the binary code, what the computer's actually working with, and the computer's not working with pictures. So even when we use those top, put in text-based things, really to the machine, that is still just a picture. So there's very little difference between this picture of a flow chart or this, what I generate here, C# code that I generated here. It's pictures that humans can make sense of, but it's still not quite what the machine runs. And last week in the Python class on Tuesdays and Thursday nights, I came up with another way to, another thing to add into this, because we've been looking at Python some. So I'm going to open up something in Python. I'll just open up idle. And that's how we were writing our programs here, using that text. We'd create some function. I'll set a function, define a function. I don't know, I'll do the same thing, call it annoy user. We'll take in some number, and then while x is bigger than 0, print hello world, and x is x minus 1. So I guess almost the same thing I just did in Raptor, except for the input. But we have this function, and we can call that, well, first off, we can use the name, and we saw this earlier without parentheses. There's a function, which means a bunch of instructions are stored at this name in this location in RAM. So well, it's there in RAM. We can go ahead and use that. Whoops, I meant to put the parentheses that time. Oh, I have to send something in, annoy user, and say maybe 12. And we get this big printout of what those instructions are. But even this, those are not instructions that the machine recognizes. The computer doesn't know what those are, right? Like, we spend a lot of time working with looking at what binary means and develop a basic understanding of it. Kind of start in that pathway for those who will work with binary in the future. But Python, we have to install that before we can even get this far on a local machine. Our computer doesn't know Python, and there's something we can do to check. I'm going to import this library and then type this instruction and have the computer look at that function I just typed up. And here we didn't, I think it got mentioned very, very briefly. We talked about computers know machine language, and when the machines get put together, they build in some instructions that that particular electronic circuit can carry out. Like, the combination of switches can only do certain things. So when they put it together, they set it up with the assembly language, which is usually connected to human readable symbols. But assembly language is something the machine knows. So the machine doesn't know Python. So what I did here is just print out the assembly language version of that. So here is those instructions I just typed, as far only closer to what the machine knows. It's going to load something in, or X, so that must be the thing we're passing in, set up a constant, and it's going to compare them. Jump if false. That sounds a little bit different than our loop instruction, right? Or anything we would think about as a loop. Loop would be repeating, but it's not, that's saying just go somewhere else altogether. Nothing about repeating or anything. It says go to line 36. So if that comes out as false, we'll jump way down here to line 36. Otherwise, we'll just keep going in order. load in some stuff, put a function on a stack, pop the function off the stack, come back in, load something in, load this stuff in, binary subtract. We can figure out quickly which line in our instructions that was referring to. Come back around, jump if true. So we come back around. Looks like these instructions showed up somewhere, and then we get jump if true, go back to number 8, which is way up here. So we go back here. So that must be referring to our loop, because we just went back up. So we're going to run the same instructions again. But the point being, this is something the computer knows what to do with. It's still pictures, so the human can read it. But whenever we type our text-based languages, that's not really what runs. When we draw our picture, it does something like this in the background. It writes a bunch of text-based code and then runs that code. But like I just looked at it over here, the codes that we work with, such as Python programming language, or Raptor writes some instructions in a language called Perl in the background and then runs those. Those still aren't what the machine knows. You can get down to assembly language, but it's still not exactly what's running on the machine. It's put in a format the human can work with. So the text-based thing, what a lot of people think about with this, that originates when computers were coming around after World War II. They started during World War II when it was a secret project, the ENIAC machines. Those were big, complicated devices, and reprogramming them actually meant taking them apart and putting them back together in a different order. It's not a very good input. Only really, really, really high-level electrical engineers could input anything to that machine, because in order to make an input, you had to be able to take the machine apart and put it back together. So after the war, when it became more of a public project, one of the ideas that people tried was they took a typewriter, a standard machine for dealing with human language and the symbols we're used to using, and added some electronic components to that so we could push the buttons on the typewriter and feed an input, which is still our main input we use. And that's where the text-based programming originated from. But something y'all have probably noticed this semester is that's kind of error prone, right? Humans are very, very prone to making a typo. Even if it's typing words that we just made up or typing in our own name, we still tend to make typos a lot. Humans are easily distracted or something. And there are some other issues. We kind of saw it with Raptor and Python. I closed them already, but when we have the flow chart, there's a picture. We can visualize something. What we're writing, whether it's words or drawing that picture of the flow chart, isn't really what runs through the machine. That gets translated through many levels. When we draw that flow chart, it generates, in Raptor, it generates some Perl code. Then that Perl code gets turned to assembly language, kind of like what I just showed on Raptor. I just don't have anything handy on my machine to, or what I just showed in Python. I don't have anything handy on my machine to show the conversion of Perl into assembly language. And then that assembly language is what finally gets turned into machine language so that something can run. So anything we do, we're a lot of steps above what the machine actually runs. And that text-based one is a bit problematic, especially with typos. Prone to typos. And when we stare at text for a long time, it's bad for our eyes. Our eyes will straight deceive us sometimes. There'll be a typo in a line and we will see the correct thing written there just because our brain knows what's supposed to be there. So it does that instinctual fill in the gaps to avoid sensory overload and just sees the right word there. So there's some problems with the text-based one. And the graphical things for years have been increasing in popularity, and getting more and more popular. So I was going to look at a couple quick pass at the samples of those. Well, we've been using Raptor, so flowchart sort of things. There's some nicer ones out there, much more modern ones, things that actually compile and run. One of the nicest ones is this this word, MENDIX. It's a French word, a French company, and I learned a long time ago not to try and pronounce French words. I think a couple of people in here came from places where French might be your native language. So, however that word is pronounced in French, they have one of the nicest flowchart style ones. I'll go over here to the website. You can get a free thing for it. I think at their platform, you can see some pictures. Yeah, so if we want to do app development, there's hopefully some pictures here. Oh, kind of small. Make those pictures a little bit bigger, but you can see it's sort of where we drag our, oh, the AI jumped the gun on me. We drag our mouse around and draw a picture of a flow chart. This particular one comes with an AI built in that can help us do this. And some people have even connected that to spoken stuff where the programmers can sit around and talk about the program, and the AI will draw that picture and stuff after, just from listening in on the meeting. So human doesn't even have to do as much as drag our mouse around. But similar to that thing we saw where we put together a flow chart and that generates, that creates the program. It's an alternative. We don't have to go through the text-based one. Some people like to, because there's a lot of resistance to those sort of things. It's well known that the text-based stuff can be problematic and comes with problems just because of the nature of it as it is, but people fight tooth and nail against it for some reason. But there are a couple other ones. So there's the flowchart ones. Those can go right to code. Sort of like what we've seen. We just drag our mouse around or drag our thumb around on a screen and put a picture together.
Like you said, it's all just problem solving. Whether you're doing it with text or with a flowchart, you're just solving a problem.
Yeah, it's all the logic is what matters. Because like on that last one that I was just looking at, I'm not going to try to pronounce that name. However, I've seen French words that are like 3 letters long and 10 syllables, and French words that are 10 letters long and only 1 syllable.
My girlfriend speaks French. You don't gotta tell me.
Yeah, I don't even try to pronounce French words, but I know how to spell
Spanish.
that.
I can speak a little Spanish, but not French.
So like on that one, the AI can do a whole lot. The AI can draw that picture, can put the flowchart together, but what the AI can't do is it's not intelligent. The AI cannot put together an algorithm. A human still has to put together the logic and figure out the flow, the steps necessary to solve the problem.
That's why I try to tell my friends who are like, oh, the computer's going to take over the world with AI, and they see AI and they get scared of the idea of it. I'm like, a human still has to write that code. Computers can only do so much on their own. They're still rocks.
Yeah, it's like that the classic phrase, the robot apocalypse. Anybody that uses that phrase has never done anything with robotics.
Exactly. Like,
they will malfunction.
We are matching rocks together with electricity. All right, we're doing our best.
Yeah. The robots will malfunction in a few seconds.
Exactly. They can't fix themselves.
Take a step to the left, it'll lose track of you. So
visions based on movement.
There's that. Another one that's really useful. A lot of people have probably seen this in a popular setting to learn with. Has anybody ever encountered Scratch? It's a small thing for introducing game development. A lot of people like to use it, and it's become very, very popular for introducing
high school
programming concepts. What was that, Tyler?
I messed with it in high school, at our high school computer club that we had going on.
Right,
We
yeah,
had a
it's-
high school programming class, but
It's
I messed with it more
it's
after.
become very popular. It's a great way to introduce concepts and make small games and things.
The
But
Scratch main little cat guy is like ingrained in my dreams.
yeah,
Make
so
him
that
throw a
is
ball.
actually using something else. It's using this thing that's owned by Google called Blockly. So
Yeah, it
those
looks
puzzle
cool.
pieces that we use to write our code on that IoT lab, the simulator I pointed you towards uses Blockly as well. So this is actually an open source thing Google has. We can download this and put this in any application we make. So we can download and include this, and I have to do it out here. So the nice thing about this is the first nice thing, I guess the only thing on the screen, is those puzzle pieces give us ways to build up our logic in sort of a visual representation without going to that traditional flow chart by looking like puzzle pieces. So we have different things here. So some logic things, so like if else structures, loops, little puzzle pieces that plug in together. And it helps to organize things because, well, like puzzle pieces, we can't connect the wrong pieces together. They sort of only plug together one way. So a little program, I'll do like, so maybe we want a prompt for something. Let's get a number, and we need a message to prompt with. So that's more text. So another little text puzzle piece, and we can build stuff up or just type it in here directly. I'll just say enter a number, some sort of thing like that. And after we get that, we can store it somewhere. So like a little variable puzzle piece, user number, and oh, I didn't give myself enough room. There we go. So you can see it connects, so that prompt will just kind of feed in. And hopefully you see how those puzzle pieces look very similar to what we did in Python. And actually this one writes code, and see it's set up to JavaScript over here. Let me change that to Python so you recognize it. They didn't use input, but that code that's generated should look very similar to what you've seen in Python a couple times. Hopefully it makes sense that text prompt is equivalent to the input thing you're used to using.
Yeah, instead of input, it's just using user number.
But you see how we use those puzzle pieces. So it gives us that nice little structure for things, how it looks together. And then we could do something with it, maybe an if else. So I'll click the little settings icon, and instead of just an if to do one thing, I'll switch it to an if else. Is that where I bring that in? I'll have to do that. And build a little puzzle piece here. So then there's the, how do I close that? Oh, there it goes. If that something about that number we got, we can either do something or something else. That standard selection structure we've seen a few times looks a little bit different here. And I'm doing it with the mouse, which is the awkward part. But we have that logic we've seen can all be done this way. And you'll see it's writing the code as we put it together. So like, what can we check? I'll just compare it. If some sort of thing, some sort of comparison like we've seen, maybe if that user number thing is smaller than, or in math and just grab a hard code number less than 3. I'm just making this up as I go along. So if the user number is less than 3, we'll say that's too small. We need a number bigger than 3. Print out That's too small. In our else block, I don't know, just to see everything, I'll throw in a loop. Oops, it goes down here. We'll repeat while the same thing there. Bring in our logic. While our user number is bigger than, say, 0, that seems like a good place to stop. And you'll notice I'm doing a lot of clicking and things like that, and dragging around. That's actually the awkward part with this. If you've encountered these puzzle pieces before, try this on your phone. This
That's what I was
is the
thinking, on the
one,
phone or maybe in VR, like using your hands.
one finger with just your thumb. Can I pull this same side up here? Probably not in a good way to see. I don't know how. It's a little small, but oh, it's not working with my phone. My phone's trying to mess up, not cooperating, but with just these puzzle pieces, they are the perfect thing to code like this. So for those of us that like to just lay back on a couch or a comfortable chair and do your work with just your thumb, this sort of low code solution is a really, really nice one to work with. It's kind of hard with a mouse. You can see it's, well, just from looking at it and maybe watching me here, you can tell it's a little clumsy with a mouse, but with just your thumb on a phone, it's a great way to write code. And what this is a plugin. We can download the source code here and just add that to any program we write. So if we have a UI, anytime we put together a UI, we can go ahead and throw this in there. If we're putting a user interface in there. Uh-oh. Probably shouldn't have. Can I go back? Probably should have finished this one. Oh, it reset everything. But all those pieces are there. I probably should have finished that. I was going to do if one thing, then do a while loop and print some stuff out. Well, I'll just go with that back to the default one. The main point was try those with your phone. Most people that have experienced Scratch probably saw that on a desktop or laptop computer where you're using a mouse, and those pieces are a little clumsy, but it's really, really nice with your phone. And then with those, just generate some code. Looks like their example here has 5 different languages, but this is a Google project, so it can generate code in pretty much any language Google knows, which frankly, if Google doesn't know about a programming language, then we don't either, right? That's how we would learn about them, is go ask Google about them. So it actually generates the code, and it plugs into things. Like their example here is just included in a website, so we can run this code, maybe do some other stuff. Oh, is it done? Oh, eventually it'll finish. Maybe I can change some of this out real quick. User number. Like that, and the prompt like we were looking at. Which there's a lot of pieces, just like writing code, and a little clumsy with the mouse. So give it a try on your thumb, but it's, again, it's really, really, let's see, less than 3, that'll still work. Plug in that variable for user number. Oh, I meant to put it in the logic. Plug this in. There we go. Got back to where we were fairly quickly. Set user number to user number -1. And what's missing here? Oh, print a statement. Print some random output. Whoops. Wow. User number is bigger than something, some random number to put in there. 0, that'll work. Oh, almost finished. You can see the little highlighting tips. You can see where things are missing. That's not big enough. Go back to what I was trying to do before I went to another page and erased it. But you can see we can just generate some numbers. Let's print out user number. There we go. The Python code might look familiar, and dragging them out around with a mouse is odd, but that is so easy to use with your thumb. And just generate that code, and then you can take that Python code and run it somewhere else. So like 5 times. And we just get the numbers printed down, or a small number, get that message. So another way to just use pictures to input our logic to the machine, to give the machine these instructions, and you'll see that it's the thing should look a little bit familiar. That's one of the very popular ones, and like I was pointing out a little bit too soon earlier because it erased the stuff. We can just download this code and include that in anything that any project we make. If our project has a user interface in it, we can just grab this code from Google and include these little block pieces and choose which languages it will generate code in. So another common way to do that. The third type of example, or the third main kind, so that's some examples of our main types. Salesforce low-code solution. I think you look at the French one. Salesforce is a very popular business tools, and they have one of these as well. Download there's like a flowchart interpreter. Is there a good picture of it somewhere? Oh, watch demo. Nope, they won't even let you watch a demo without paying for it. Oh, I don't see the one I was looking for, but I'll go back to that last thing. There are lots of these out there. So the traditional text-based coding isn't necessarily our only option, is kind of the thing I was getting at. There's different places where we can apply this, which for most people, wait, is that not what we just looked at? Oh, the page is zoomed out. That's why it looks so strange. So we have things where we build flow charts. We've seen a couple of those. I don't remember where the good pictures were. Let me try to, is it here? Nope. Here. Ah. Things where we build up flow charts. It's a lot more common for our flow charts to go horizontal than vertical. The one we looked at most of this semester was going vertical, but that's one common way to put together logic and then just generate the code. A bee just landed on my nose. That was a little disturbing. Build a flow chart and then we can generate code from it, or most of the modern ones will compile directly so that we don't need that intermediate human readable step. We just send it to machine language immediately from the flow chart. Also have little things like this, the puzzle pieces, that's what I like to call them. We can include that anywhere and just generate code from that. The third main type is node-based things. Whoops. And the examples I had to show on this, the ones I had convenient are, none of them are simple to look at. I'll point at this one. This one's becoming very popular very quickly. Machine learning is going to be a huge deal moving forward. There's a lot of things around that. And for a long time, Python was the most popular way to do machine learning. But that has, it is kind of taking a backseat now to, again, low code solutions. Can I just open some examples so we can look at the pictures? Nope. I'll have to make a new one where we use these sort of workflow things. Was there something about that? There we go. Visualize some nice stuff. We bring in these little symbols and connect to different things. So go from a database into a table, run that into do some correlations and randomize our numbers, show it how to work. And we build up little flows of how to work with that stuff instead of the very abstract text-based things, because unless you've gotten to high-level mathematics, a lot of those words are going to seem really strange. Merge that into something, and I'll give it a rank. That's probably a good place to start it. So grab some data from a database, organize it into a table, look for any correlations, use those correlations as a seed to randomize that data, put it back together, and then give it a rank. Just kind of scatter stuff. The main thing I was just pointing at the tool, but very quickly replacing Python is this thing Orange, which is another low code solution. We drag our mouse around and then all of the code's written in the background. It's like that thing I put on the board. Even when we write text, that's just a picture. It's just a picture of the letter A. So we can do much better with our pictures is the idea behind it. It's less error prone. There seems to be a lot of resistance to the change. These things go back to like the 1980s. It's not a new idea. People knew the text was problematic and started trying to do this as soon as computers could handle graphics to begin with. And there was just pushback from it. Like Intel released a machine learning curriculum for colleges to use, and they were using Orange a lot because that's quickly becoming the most popular way to do it. And all kinds of people were freaking out about the meeting that wasn't written in Python. And we see that stuff all the time. This one's kind of complicated. It's a node-based thing. So I wanted to do one where we'd actually see something used. It's going to take about 10 minutes. The node-based ones are usually for more complicated scenarios. I went over a couple things. The options I have to show something are like orange that I just showed, where, but we drag our mouse around instead of writing text, and the computer writes the code directly in the background, so we don't need that stuff. So that one you would probably get very, very lost very quickly if I tried to do an actual example. And then the left the two that I had to work with, like some graphics things, which either developing graphics themselves, like open Blender and show those solutions and compare it to the Python code directly, or just a video game thing. So I was like, well, a video game might be a little easier to follow. So I started setting something up here. Oh, my background's in the wrong spot. Move that to 10. There we go. So just nothing really fancy here. I grabbed one of the scrap backgrounds I had around and a character from a week or so ago in the game development course that we threw together really quickly. So our character is animated, but a big part of the game is we want that character to move. So we need something to happen when I come over here and like push the D key or the A key. Might be a good start. Traditionally, again, done in text-based coding, which is itself abstract and separated from it, and very error prone is the biggest thing. Humans tend to make typos in those. They're error prone, and the text is separated enough from the graphics that it's hard to feed that, to reform that connection, and things constantly end up in the wrong order and stuff. So one of the, so on all our major game engines, they switch to this quickly, much quicker than other places. As you're heading into software development, low-code solutions are more popular than text solutions anymore. And really, it's academia fights back against it. I don't understand why at all. People are like, no, this isn't how we did it in 1985. It seems to be that sort of mentality that leads to the
All the crabs must boil.
determination to use text. Even though study after study shows the other ones are superior. So the low-code solutions are out there. I wanted to at least talk about a few of them. But our game engines took to those very quickly. And they use mostly node-based ones. So that's another example. That's the category that orange one fell into. I wanted to point you towards that because we did look at Python, and at places you're probably going to hear that all the machine learning stuff about Python, and that's kind of a couple of years old now. Technology moves quickly. So you want to make sure you're staying up to date on technology. So you're going to see a lot more of those low-code solutions there as well, because it's quickly taking over the field like it did in normal application development. Low-code solutions like the flowchart, drag and drop things, those are immensely popular for mobile app development. Way, way, way more popular than text-based coding. So as you're progressing forward, academia seems to be lagging behind quite a bit. And for some reason, there's a tendency in academia to struggle against that change. It's like the main ones fighting back. We're like, no, we need to use text-based things. And then people get software development degrees and go to get jobs. And it's like, oh, text, that kind of fizzled out 10 years ago. So just to make sure everybody's aware of that stuff progressing forward.
Good to know. Good to know.
Yeah. Yeah, academia is slow to change. Y'all have probably encountered that on your way through school, right?
Yeah, that's
especially
true.
high schools. High schools are like the most resistant things to change ever. But these things available, it's not gone away. It actually, please don't get me wrong and think ignore the text to do this other stuff. It added another tool, right? If you know people that are like
yeah, it's all conceptual.
Yeah, construction workers, even if they have lots of tools in their truck, they're going to constantly buy more tools, right? It adds more tools to our toolbox. I couldn't think of another word there quick enough. So we kind of need to be familiar with both. So I'm not saying ignore text, I'm saying don't ignore this, this sort of thing as you progress. So the ones in video game editors or engines are node-based things. I set up that picture, we just need that to move. So the node-based things involve little graphs that we put together. I'll stick this down here somewhere. That'll probably get enough room. So I have to make a couple pieces so that we can control this. So I'm gonna create a piece here that, yeah, I have to get into a lot of details. I'm gonna create we call them macro, either a state that's step by step where we're at in the game, or flow, how we get between states. The flows are a little more intuitive, so I'll create one of those. And then on our character, add in a controller to apply that control. These are things I probably could have set up earlier. So now it's attached to the character, so I'm going to control the character and come over here and use a visual representation to put together some code. There are two big things, whether we're doing it in our game engines, whether we do it with text or this one. The result is exactly what we would get if we type this in C#. We have two methods that we use a lot: start and update. And basically this runs once whenever the game starts, and then this runs at every frame of the game. So as far as our character moving, oh, whoops. Probably want to use something like this. Oh, I
Is that
forgot
why
to bring,
frame rate and time in games are so closely tied together? It's like
yes,
okay.
yes, frame, I like to use the frame rate when I'm timing things. It keeps track of things because we set it up. Every frame of a game is a new state of our program. But to make our character move, we just need to check something, right? A selection structure is like, if we're pushing the D key, our character should move to the right. So we grab these little nodes and make connections between them. So maybe some sort of, I'll search for an input thing, get an input. So I want to get this input called, well, there's a pre-built thing called horizontal axis. I'm just going to grab that. The horizontal inputs, which by default are going to be the A and D keys. So every frame of the game, I'm going to look and see what the D key is doing. And after that, I can grab this little branch, which is essentially like an if-else structure, which this is kind of odd. I forgot my good mouse where I had all the controls. I don't have a way to move this around. Will this work? Nope. I have to zoom in and zoom out and zoom in at a different place. But a branch is like an if structure. So if this button's being pressed, then we'll move the character. Otherwise, we'll move the character. And to check if it's being pressed, that gives us a number that's, if it's not being pressed, it's a 0. If it is being pressed, we get somewhere between -1 and 1. So we'll just check those. So we can check, yeah. If the horizontal inputs, which is the A or D keys, are not equal to 0, so the words there should sound very familiar for what we're doing, then that's a condition for a branching structure, which looks, the selection structure, the if else, or if we think about the flow chart, that's what it actually looked like, right? It made our flow chart split up into 2 different branches. We have these little nodes where we control things. So if it's false, then we can just not do anything. Because if we're not pushing the key, then we can just not move. That's a good false option. But if it is, then we need to move our character. It's behind the zoom thing. That's transit. And I'll change the X position. Multiplying whatever our input is, because like I said, our input is going to be some number between -1 and 1, 0 if it's not being pressed, -1 left and +1 to the right. So if I multiply that by some speed, maybe 0.1, we'll see how fast that is. Change the X position. So the picture might look like a mess there, but the general things I was talking about, those should sound familiar from what we were looking at in class, right? We grabbed some input value. In this case, I used some pre-built things there, so the words might have looked odd, but the A or the D keys, the ones we use for a game. And if it's not equal to 0, that means neither one's being pressed. And we'll check it with a branching condition structure. Not equal, if it's not being pressed, we get a false. Won't do anything, but if it's being pressed, we want to change our X position. Change our X position to whatever we did get from that key press times some small speed, like -1. So now if I run the game, instead of the character just standing there, he should move. I was talking the whole time. Oh, yeah. So kind of fast. But you can see that logic, instead of the traditional text-based thing that's completely separated, is there. And these are called node-based solutions. These usually compile directly down. And if you look at that, you should see a huge advantage we have over text with this sort of thing. Right?
And that's how you code in Unity? Like,
this is the official one in Unity. C#
that doesn't
is
look too bad.
Oh no, it's quite easy.
Okay.
It's very, very easy to use. I've shown a whole lot of people how to use it and made some pretty advanced games in a couple of hours. Unreal's had this since like 2015, something like it. Then theirs is the one in Unreal is better. The Godot, for those people who like the FOSS Linux users, yeah, it's had this since 2015. I don't think they even finished out the year after Unreal added it before they did that. And most of our game engines have things like this.
And that's called Godot?
Godot is a Linux one, but a nice powerful engine to work with.
I'm gonna check it out.
What engine did Disney have that Pixar has for their?
They have a few. There's a lot of them out there. But so yeah, those are the getting into game engines is two entire classes. So we don't need to get too far into game engines here. But I was just showing about the low code solutions, because you should also see these in business settings and stuff. But these are the type that are popular for game development. And the reason is it's so graphics heavy. When we do fancy 3D graphics, the control programming that is typically done with this same sort of solution instead of directly typing in the Python code. We use these little nodes, but do you notice while this is running, we can see the data flowing through here. That's one of the biggest advantages. So like if right now it's 0, so 0 is equal to 0. So we get a false and don't go any further. But if I push the key, we get a 1. So then true comes, we see the true coming through there. And it flows through here. And with these, a big advantage of these things over text is that visual representation where we can see our character or see our data flowing through the whole way. So that's called Bolt visual scripting, is the one in Unity. BOLT, I've written the file name. That's the one Unity uses, but most of our game engines have things like that, because text came about because in 1945, when they 45 to 47, when they needed a way to make inputs where they didn't have to take the whole machine apart, they modified a typewriter. It worked, but by the mid 1950s, they already knew there was problems with that, right? The typos and things. So as soon as graphics came about, they started doing those solutions, some sort of visual solutions. And that's sort of a quick glance at our three base ones. So node-based things, where we have those different nodes, and I already closed Orange. I should have left that open. Or same thing in Orange, which is specifically for machine learning. So similar things. And grab some data from a file and clean it up a little. I'm just kind of clicking some random things here. But you'll see there's a flow between these different things. And we build up these nodes and connect the nodes, and then those translate into instructions the machine knows. So machine learning is that's becoming very popular in machine learning. It's been in game engines for a while. Unity was the last one to actually officially add one in their game engine, and they did that in 2019, I think, is when they officially added it. And they were the last big engine to officially add it. Or the little block puzzle looking pieces, those are best on with just your thumb on a phone. They're a little clumsy with a mouse, but if you're one of the people like me that likes to do everything on your phone and do it all with your thumb, then this is definitely the easiest way to go. Well, next to dictating, but dictating computer code, like typing up Python with the dictation, is clumsy at best. Definitely a little clumsy, awkward to work with. Or the flowchart interpreters like we've used, only there's modern ones that are much, much nicer than that one we used this semester. And they almost all go horizontal. Like this one here, there's an AI that can draw the picture for us. We just have to explain the algorithm to the AI. It's a really nice one. You get 30-day free trial, so you can go to that and give that really nice flowchart thing a try, as opposed to the one we were working with this semester. So low code solutions, and don't misunderstand me, it's not, we don't want to ignore text to do that, but we don't want to ignore those. Those are powerful, powerful tools that have a lot of advantages over the text. So keep those in mind as you progress, especially the people that aren't going directly into software development, where coding stuff is going to be a rare occurrence. You might have to do it every once in a while. The low code solutions can be a lot better because you get that visual representation to help you remember things and organize it. And well, like we saw in that node-based one, when I threw it up in the game engine, with the nodes, when they're running, we can usually get the visual representation of the data actually flowing through our program, which makes it a whole lot easier to track down problems, because then we can watch the data move through the program and see where it goes wrong. Has a lot of advantages. Obviously, they are slower, right? Everything we do with the mouse is going to be slower than the keyboard, because well, the mouse usually has 2 to 6 buttons, and keyboard usually has around 100. So we have a whole lot more control with 100 buttons than we do with the 3 buttons. But there's a broad spectrum of tools. So you don't want to discard them, because especially in academia, for some reason, there's a huge pushback against those things. And it's very counterproductive from a common tool in the industry to be almost ignored. Not mentioned. A lot of schools won't even mention those things on the way through. That's one of the reasons we at least use a flowchart interpreter here when we introduce them, so that you know that text isn't the only way we have to write a program. Powerful tools, very, very useful. They have some advantages and disadvantages, and that's why neither one is probably ever going to completely take over the field, because any way we approach it, there's always advantages and disadvantages. That trade-off, which is something that you need to analyze situational as far as which one's best. I just wanted to look at a couple different ones so you have some sort of idea of what's out there. It's not programming isn't solely sitting there typing keywords and symbols at a typewriter like keyboard like has been done since the 50s. We have those other powerful tools. They're worth looking into. Again, advantages and disadvantages everywhere, so you have to adjust it for the situation. But I mostly wanted to let you know they're out there and at least take a quick look here at the main types. So that's our main types, the blocks, puzzle sort of things where we lock pieces together and they only fit together. Our instructions only fit together in certain patterns. The node-based thing or the flowchart-based thing are the main types of low-code solutions. Okay, that gets us up to 220. So that leaves us a whole lot of time left in our scheduled block, right? From 220 to 450 is 2.5 hours. And we're coming on the end of the semester, so I know most everybody has things to do. If you happen to have already got everything finished, you're probably due for a break and a chance to relax. So that's what I was wanting to do today, is make sure there was lots and lots and lots of lab time to work on final projects, past due assignments, quizzes, anything like that. So as normal, from now until 4:50, our scheduled block of time, I'm going to be sitting here ready to answer questions if you have them. As always,
That's it.
As always, Ivy Learn messages and text messages are two things that make noise on my phone. I can jump back on a Zoom call in a split second. Please use our time productively. Use this to work on your final project if you haven't got that yet. Past due assignments. If you need anything open back up, let me know. Some of the quizzes locked, or I know some of the textbook quizzes, I think only gave you one chance. So if you did poorly on one of those and would like to bump up your score, send me an email and I'll unlock it for you. Or anything that's locked, let me know. I can unlock those to improve scores or something. But please use our time productively. I'll be sitting here ready to answer questions if you have any until our scheduled block at 4:50. And well, then I have to grab dinner and get ready for my 6 o'clock class. But please use our time productively. Let me know if you have questions. Otherwise, that was it for today. I'll give it a couple seconds. Anybody have questions before we wrap up?
I'm downloading that Godot. It's not really a question, but I'll let you know if I have any questions about that. I'll poke
Okay.
around in there.
Yeah, it
Try not
is.
to get too distracted. I have to do that final project, but you know.
Yeah, it's
fun.
a modern game engine. That's the free open source Linux one.
I gotta try Blender too, but that's a whole nother.
Okay, yeah, I can show you a lot of stuff on Blender. If you have
That's where you
questions
do all
about game development
graphics to
after you get
import,
your
right?
project, after you send me your project, I'll address questions about game
Oh,
development.
that's fair. That's very fair.
So, any other questions? Okay, so please use our time productively. Let me know if you have questions, and I will see you all on Monday with a couple more, something that I think will be very useful for everybody along the way with the knowledge from this class. So I'll see you all on Monday. Have a good weekend.
Did you see you?